Welcome everyone. This class will be the second part of this acids, bases and salts. So it is the part second of acids, bases and salts. And there were the theories of acids and bases, and those were the Arrhenius theory, Bronsted-Lowry theory and the Lewis theory. So theory of today's heading will be theory of acids and bases. First one will be the Arrhenius theory. Arrhenius theory. So according to the Arrhenius theory, acids gives H plus ions in aqueous solution having water, and bases gives OH minus ions in aqueous solution. So it was the first theory, which was that Arrhenius theory. Now come to the second one. Second one was the Bronsted-Lowry theory. According to the Bronsted-Lowry theory, acids are those who lose proton, who will lose proton, that will be acids, and bases are those who receives proton or gain proton. It was the Bronsted-Lowry theory. And the third one was the Lewis theory. Lewis theory you will study in the 11th class. So there is not much detail about this. Just to know about the different theories, I am telling you these things. According to the Lewis theory, acids have no lone pair. No lone pair means no lone pair means if all the means if all the electrons are bonded, means if there is complete bonding, there is no lone pair, so that will be acid, and bases have lone pair. Means if the element is not completely bonded, if one pair of electron is left, so that will be a lone pair. So if lone pair is present, so that will be the base. If lone pair is not present, all the electrons are bonded. Valence electrons are bonded. Valence electron you will bond. So if all the valence electron will be bonded, so there will be no lone pair, and that will be called as acids. And if there will be the lone pair, so that will be the base, according to the Lewis theory. Now we will study about the indicators. You will study in detail about the Lewis theory. It is not present in your 10th class. Only this Bronsted-Lowry theory and this Arrhenius theory is present in the 10th class. Now we will study about the indicators. An acid base indicator is the one which exhibits different color in acids and bases, which exhibits different color in acids and bases. Meaning is that an indicator is the one which will show the different colors in acids and bases. After that, you can note down one thing. Red cabbage is a visual indicator used to detect acids. Onion, onions are olfactory indicators. Litmus is a natural indicator. Extracted from lichens or lichens. So from where you will get this litmus? From lichens, which will, there will be symbiotic relationship between algae and fungi, and from that symbiotic relationship you will get litmus from lichens. Now, apart from natural indicators, there are few synthetic indicators as well, such as methyl orange, and phenolphthalein. Now, we will study first of all about the natural indicators. Natural indicator is the litmus, you know, purple in color. It is made into blue and red color for detecting color changes. An acid turns blue litmus to red. Example, orange juice. Second one is the a base turns red litmus to blue. Example, NaOH, which is a base. Other example of natural indicator is turmeric. It turns red in basic solution. It turns red in basic solution. For example, you can say yellow curry on white cloth. Turns reddish brown when soap is scrubbed on it. Other example of the natural indicator is red cabbage. Red in acidic solution. It turns red in acidic solution. But turns green on adding to basic solution. So your turmeric will become reddish brown in basic solution, whereas the red cabbage will become red in the acidic solution but will turn into the green color when you will expose it to the basic solution. Other examples of the indicators are the China rose, red cabbage juice, so you can write down the changes in the color of those one indicators as well. China rose, red in color, and in the acid it will turn to the magenta color, and in the bases it will turn to the green color. And red cabbage juice which is purple in color, in acid it will turn to the pink or red, and in the bases it will turn to the green or yellow. Now we will talk about the synthetic indicators, which is very important. Synthetic indicators, I have told to you, methyl orange, which is neutral in color, sorry, neutral color is orange. And in acid it turns to the red color, and in bases it will turn to the yellow in color. Next one is the phenolphthalein. I'm sorry, spelling is wrong. Phenol. Phthalate. Here somewhere where I have talked about this natural indicator. Apart from that, here one L will be also here. Phenolphthalein in acids, it is that neutral color is colorless. In acids it will be colorless, and in the bases it will turn to the pink color, which is magenta color, pink, or you can say magenta. So you will remember that indicators, what are the indicators? Indicators will change in the color when you will add those indicators in the acids or bases. Next one is the olfactory indicators. Those substances whose smell changes in acid, in acidic or basic solution are called olfactory indicators. Smell changes. like onion. Bases destroy the smell of onion. Whereas acids cannot destroy the smell of onion. Similarly, vanilla, which is also a olfactory indicator, bases destroy the smell of vanilla, whereas acids cannot destroy the smell of vanilla. So bases will destroy the smells, whereas the acids will not. So it was all the part second. Thank you all of you.